Hello guys, this is Paul McWhorter from TopTechBoy.com, and we're here today with lesson number 18 in our incredible new tutorial series where you're learning how to do 3D graphics and 3D animations in Python. What I'm going to need you to do is pour yourself a nice strong cup of black coffee. That is straight up black coffee, no sugar, no sweeteners, none needed. That's your go juice. Go get you some. I'm also going to need you to call up your most excellent Visual Studio Code. And as you are calling up Visual Studio Code, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and let's talk about what we are going to do today. What we are going to do is we are going to look at the solution to the homework assignment which I gave you in lesson number 17. And what that was, we had a clock visual, an analog clock visual that actually kept time. But the problem was that the hour hand and the minute hand didn't move smoothly like an analog clock does. They would jump on the minute or on the hour to the next position. What your assignment was to go in and make it behave smoothly like a real analog clock. Now you guys should be playing along at home. If you've kind of gotten lost somewhere along the way, I have tried to help you out. I have put the code that we ended up with in lesson 17. So if you've kind of fallen behind, you can go to the most excellent www.toptechboy.com and you can search for Python 3D graphics tutorial 17, and then down here I have the code for you. You can click on these two little page icons. It'll select it. You can copy that code. You can come back to Visual Studio Code, and then what we'll need to do is we are working in our Vpython folder, and then what you can do is create a fresh new Python file, and I think I'll call this clock proportional.py. The .py is kind of important. Boom, and we got a fresh new Python program just ready to be written. Let's go ahead and paste in here the code from lesson number 17. Okay, so now where did we end up with in lesson number 17? Well, if we right mouse click and if we run it, we can just hit the run button there. And then we pop up with our visual and boom, look at that. It says that it is 10:43. Okay, 10:43, and I need to do a little Windows management here real quick. Just give me a second. Okay, that fixed it. Had to get it where my cursor showed. Okay, so this is showing that it is 10:44 or 43, and then when we get here, boom, the minute hand goes to the next minute. Now this kind of is showing the accurate time. Where I am here, it is in fact 10:44. It's going off and it's grabbing the time from the system clock, and then it gets an hour, it gets a minute, and it gets a second, and then we're displaying those. But what is the problem? Well, do you see our hour hand here is still pointing at 10, to where really the way a real hour hand would be, it would be moving almost to 11. So the way this works is the minute hand stays on the existing minute until you get to the top of the minute, and then it goes all at once. And similarly, the hour hand keeps pointing at the present hour till you get to the next hour, and then it pops. And we really don't want that. What we want is we want it to move proportionally. So were you guys able to make it work? I gave you a homework assignment. Leave a comment down below that you are a legend, you got it working, or you folded up like a cheap Walmart lawn chair. Okay, let me know if you guys were able to get it working. Now, one of the things I talked to you a lot about is you want to get these things working on paper before you try to go in and code them up. And sort of the way that we have this working now, we can put the hands at any angle that we want, any angle from 0 to 2 pi, 0 to 2 pi. We can put those hands at any angle that we want. We just have to figure out what angle we want them at. And the way we did this initially is shown here. That we sort of said we got the angle of the second hand by saying how far is it all the way around? Well, it's 2 pi all the way around. And then what fraction of a full circle do we want to go? Well, it's how many seconds we have divided by 60. So if we were at 0 seconds, we would be at 0 angle. If we were at 60 seconds, we would be all the way back to 2 pi, which would be straight up. But what if we were halfway around? Well, that would be 30 seconds divided by 60, and that's 0.5, and then 0.5 times 2 pi, that would put us halfway around. So this little neat thing for the second angle, the minute angle, and the hour angle works very well. Now, we sort of explained how to get this in our earlier video, but because we've got to play with this a little bit, I want to review it just a little bit so you kind of remind yourself of where you are. Okay, so the seconds divided by 60 is what fraction of the circle we would be around, and then we multiply it by 2 pi, which is how far it is all the way around. Well, what is this plus pi over 2 business? Well, what we know is that in Python and in trigonometry in general, the 0 angle is out here pointing to the right. So it's sort of like the positive x-axis is the 0 angle. But for a clock, the 0 angle is straight up and down. And so we want to move that 0 position from here to here. So we just simply add pi over 2, and that renormalizes our scale, so it's like 0 is not here, 0 is up here, because 0 is up here in a clock. Hopefully that makes sense. So that explains what the plus pi over 2 is. Now, what is this negative sign here? Well, normally in math, counterclockwise is the positive direction of rotation, and so the positive direction of rotation in the math world is counterclockwise, but in the clock world it's clockwise. So we put these negative signs out here, and by putting the negative signs out here, it makes things spin the right way. So we're sort of normalizing our clock to the way the math world works. So the plus pi over 2 makes 0 straight up, and then the minus makes the clock run the correct direction. Hopefully that makes sense, and we talked about that quite a bit. Okay, now to make this thing work proportionally, there's really nothing we can do with seconds because we just read in seconds. And if you look at the second hand on a clock, it does sort of click in 1 second increments. And so this is going to stay the way it is because that is the way that a clock works. But if we look at minutes, we go out and read the minutes from the system. And so like if we look right now, I am at, it looks like 49 minutes. I am at 49 minutes. It's going to stay at 49 minutes until the second hand goes all the way around. So it's going to stay at 49 minutes, and then it's going to go to 50 minutes. Well, instead of those, that's sort of like integers, 49, 50, 51. I don't want to do that. I want to have fractional numbers. I want to have decimal numbers so that when I get to 59 seconds, this minute hand is almost to the next one. So it's moving proportionally like a floating point number, not in solid jumps. And so the way we would do that is we would come over here, and you know that minutes is an integer. So what we want to do is we want to add to it what fraction of a minute we have. And so to kind of make it simple, we're just going to say this. We're going to say minute angle, our new minute angle, our improved minute angle. It is going to be, let me get all the way out of your way, it is going to be minus like we had before, and then it is going to be minutes divided by 60, this whole thing divided by 60, but then I want to add some decimal minute, like what decimal minute do I have? I want to add that and then still multiply by 2 pi and then add pi over 2 like we were before. Now, what is the decimal minute? Well, think about this. If I am at 0 seconds, what fraction of a minute do I have? 0. If I'm at 30 seconds, what fraction of a minute do I have? 0.5. If I am at 15, okay, if I am at 15, what fraction of a minute do I have? Well, it's 15 divided by 60. Or at 30 seconds, it's 30 divided by 60. Or at 45 seconds, it's 45 divided by 60. Or if I'm at 59 seconds, that would be 59 seconds divided by 60. That's almost, that'd be like 0.97 or something. So you see, what we want to do is then we want to say, what is decimal minute? Well, decimal minutes is equal to seconds, how many seconds I have, divided by 60. Okay, so what I want to do is I want to take this and add it. So then what is the angle that it's going to have? Well, it's going to have minutes plus what the fraction of a minute is, and then divide that whole thing by 60 here. You want to make sure that you do your parentheses right. So you're going to have minutes plus seconds divided by 60, and then that whole thing divided by the 60 minutes in the hour. And similarly, for the hour angle is going to be equal to, like we had before, minus hours divided by 60 plus what? What is your decimal hour? Times 2 pi plus pi over 2. And here, what is decimal hour going to be? Well, it is going to be minutes. How many minutes do I have? Divided by 60. So if I have 30 minutes divided by 60 minutes is 0.5, and that means instead of being like at the 1 position, I want to be at the 1.5 position, halfway to 2. So let's say it is 130. Well, I would be 1 plus 30 divided by 60 is 0.5. I would be at 1.5. I would be halfway between 1 and 2. Does that make sense? This is really, really very easy, I do think. So what we're going to need to do is we are going to need to come back to our code, and then we will be checking back with these things here as we go. But we need to come into our code view, and I think I am going to go ahead and kill this now. And then I'll come here and I will kill it here. And so this is, we need to come down and here where we calculated, let's see. Oh, and I think I misspoke here. I think that I did misspeak. I hope you guys were yelling at me here. I made a mistake here. That how many hours are there? Well, there are 12. So it is, the hour angle is hour divided by 12. It's hours divided by 12 times 2 pi because it's 12 hours to get you all the way around. And so like if you think if I'm at 6 o'clock, well 6 divided by 12 is half, so I'm halfway around. So I made a little typo there. And then similarly, the hour angle is going to be minus hours divided by 12, okay, because there's 12 hours in a revolution. But in fact, On minutes, there are 60 minutes in a revolution, so this 60 is correct. It's just for hours you divide by 12 here. For hours you divide by 12 here. So I made a little boo-boo there, but I hope you guys understand it. We're just talking about fractions of a circle. The fraction of a circle in minutes is minutes divided by 60. The fraction of a circle in hours is hours divided by 12. Okay, so let's come over here, and with that straightened up now, we should be able to come over and fix this. And so we need to fix, first of all, minute angle. And minute angle, you've got to use parentheses here because the whole thing has to be divided by 60. Okay, and so you have to add a parenthesis, and then you have to close the parentheses. And now when I add my what? When I add my second divided by 60, okay, so I take minute, I add second divided by 60, and then that whole thing is divided by 60. Now, how do I know second is right? Because up here, I read in seconds in second. And that is for the minute angle. Now we got to fix the hour angle. And so same thing, this whole thing has to be divided by 12. So I take the hour and I close it. And then what I'm going to add, what fraction of an hour am I at? Well, the fraction of an hour that I am at would be minute divided by 60. Okay, minute divided by 60. So let's think about this. If I am at 0 divided by, if I'm at 0 minutes, 0 divided by 60 is 0. I'm just on the hour. If I am 1 minute past, then I'm going to add 1 divided by 60. I'm going to add just a little bit to the hour hand. If I'm at 59 minutes, then 59 divided by 60 is almost 1. I'm almost to the next hour. Does that make sense? I really hope it does. Okay. Again, you've got to make sure that you do your parentheses right there. You've got to make sure you do the parentheses right there. Again, this minus sign is to make the clock run clockwise like we want it to. And then this plus np pi over 2, this plus pi over 2 just makes this be the 0 position rather than this be the 0 position. Hopefully that makes sense by now. Do you see this is really simple if you're just thinking in terms of fraction of a circle? This in the brackets is your fraction of a circle, and then times 2 pi, which is what the whole circle is. Okay, let's come back over here and let's run this thing and see what happens. Boom. Okay, I want you guys to see it is 10:58. And at 10:58, can you see the hour hand is almost, to 11? You see, this is 10 and it's almost to 11. So that hour hand is right. Then do you also notice, watch when we come down here to 30 seconds, this minute hand should be halfway between those tick marks. Boom. Perfectly, right? It is right between those tick marks. And then as this moves up to the top of the minute, you'll see that the minute hand is moving over. So like right now, we are 3/4 of the way to the minute. Okay, we are now more than 3/4 of the way to the minute, and now we are coming up on it. But you see, when it gets to the top of the minute, it doesn't jump. It just is smoothly made it to the next minute, which is 10:59. And then also, we'll let it go around one more time. We're kind of fortuitous here. We'll let it go around one more time, and you see this works its way to the next minute, as this is almost to the next minute, almost to the hour. But when we get to the hour, you're not going to see anything jerk. It's just going to be naturally pointing right at the hour. I hope you guys understand that fraction of a minute, fraction of an hour thing, because it's really goes into a whole lot of important engineering things. Even though this is kind of a fun little clock demo, thinking in the way that I've tried to get you to think, it's really important. Okay, you can see that we are almost to the top of the minute, and we're almost pointing right exactly at 11. Okay, boom, there you go. So that was pretty fun. Was you guys, let me know what experiences you had. Were any of you guys able to figure it out? I think, again, there was the easy way to do it or the hard way. And if you try to do it the hard way, it was going to become impossible. But you can see that if you just think in terms of fractions of a minute or fractions of an hour, this actually turned out to be pretty neat or pretty fun. Okay, this is your homework for next week. I want you to go in and dress your clock up. Okay, I've just kind of done a really simple clock, but I want you guys to make a snazzier clock. And then what I want you to do is either capture it with your phone or capture it with a screen capture and then post it to YouTube. Leave the comments, leave a link in the comments below so we can kind of see what each other comes up with. But let's see who can come up with the snazziest analog clock between this week and next week. Then what I'm going to do next week is the lesson next week, I'm going to start showing you how to put text on your 3D graphics. And so you can imagine where we would be going with our simple clock demo with that. Okay, guys, I hope you're having as much fun taking these lessons as I am making them. I am really, really having a great time with this. It's a huge encouragement to me when you leave comments down below. I do read every single comment. If you enjoyed this video, give us a thumbs up. And if you haven't already subscribed to the channel, when you subscribe, make sure that you ring that bell. Make sure that you ring that bell so that you get notifications when my new videos are coming out. Again, Paul McWhorter from TopTechBoy.com. I will talk to you guys later.